Hi, my name is Matthew, and this video is about simplifying radical expressions, which can get a little tricky, but the more exposure I think you have to the frequently used numbers in these problems, I think the easier your life is going to be when it comes to solving problems like these, or evaluating expressions like these. So let's go in and have a look at some of these problems. This is asking us to simplify the square root of 64x squared y. And if you wanted to, you could really sort of tear this apart and write it as the square root of 64 times the square root of x squared times the square root of y. And the square root of 64 is 8, or you can think of it as plus or minus 8. And the square root of x squared, because they both have even indices, we should really be writing the absolute value of x. And then the square root of y we're just kind of stuck with. I don't know what the square root of y is. Now, as far as the plus or minus in front of the 8 goes, whoever your instructor is, or depending on the test that you're taking, or if it's a multiple choice situation, or if it's a word problem, you're going to have to decide based on sort of the environment that you're in, whether or not that plus or minus is appropriate. Now, let's see, what's over here for part C? All right, so part C is a rational expression involving a cube root and 108. 108 is definitely divisible by 9 because 1 plus 0 plus 8 equals 9. 9 goes into it 12 times. 12 also contains a 3. Let's give the 3 to the 9, making the 9 a 27. And when you take the 3 away from the 12, it becomes a 4. So this says negative cube root 27 times the cube root of 4 times the cube root of x to the 6, all divided by the cube root of 125. Now this we can simplify partially. The negative is going to keep hanging around, and it's still going to be a fraction, so I'm going to put negative and then the fraction bar right next to it. In the denominator, because that's the easy one, I know that the cube root of 125 is 5. In the numerator, I actually happen to know that the cube root of 27 is 3. And then I'm going to jump to this last factor that says the cube root of x to the 6. And this is going to be, remember that this is the same thing as x to the 6 to the 1/3 power. If that's helpful to you, because then you can multiply those exponents together and get x to the 6/3, or 1/3 of 6 is 2, we have an x squared. And then there's this. We can't simplify that any further. If it were the cube root of 8, it'd be a different story. We could knock it down to a 2. But in this case, we're sort of stuck with it. So there is our cube root of 4. And this, while it's not the most attractive answer you've ever written up, is the final answer. So there's an example of a quotient. And then part D here is a particularly good one. It's similar to part C, but something kind of special happens in this one that we haven't seen yet. Special might be a little bit of a force. It's unique compared to what we've seen so far. The 5 is on the outside of the radical, so we're just going to rewrite that. And then we have the 4th root of 64. That's kind of nice. If 64 can be written as something to the 4th power, then the 4th root and the 4th power are going to cancel out. But that's not the case. And this is why it's nice if you know your numbers. So 64, I happen to know that 32 is 2 to the 5th power. And 32 times 2 makes 64. So you take 2 to the 5th and you multiply it by 2 and you get 2 to the 6th. So this is the 4th root of 2 to the 6th. Not good. The 4th root of 2 to the 4. That would be nice. The 4th root of 2 to the 8. That would be nice. But 6 is not divisible by 4. So here's what I'm going to do. I'm going to write this as the 4th root of 16 times the 4th root of 4, because 16 times 4 is 64. And then I'm going to multiply that by the 4th root of x to the 4 times the 4th root of x to the 3. X to the 4 times x to the 3 makes x to the 7. Times the 4th root of y to the 8 times the 4th root of y to the 2 times the 4th root of z to the 8. Why did I do that? Because well, let's take it one step at a time. The 5's not changing. The 4th root of 16 is asking me what number times itself 4 times would give me 16. And the answer to that is 2. 2 to the 4th power equals 16. We're stuck with the 4th root of 4. Can't simplify that any further. The 4th root of x to the 4, that's a nice one. These 4's in a way cancel each other out and give us x to the 1. Really, we should write the absolute value of x. Now, the 4th root of x to the 3rd, okay, stuck with that. And now, remember that what this is saying, if we wrote it in exponential form, would be y to the 8th power, and then the 4th root of that would be raising that to the exponent of 1 over 4. And the power rule for exponents says that when I have a thing to a power, I can multiply those powers together. In this case, I'm multiplying the 8 times 1/4, which gives me y to the 8 over 4. And when I say 8 over 4, I really mean 8 divided by 4. And I like 8 divided by 4 because 4 divides into 8 evenly. It goes in 2 times, so we have a y to the 2. Now, if I had left this as the 4th root of of x to the 7, 7 is not divisible by 4. If this were x to the 7 to the 1/4 power, which ended up being x to the 7/4, that's not helpful to me because this 7 is not divisible by 4, not evenly anyway. Now, if this 7 were a 4, that would be a different story. That would be nice. And so what I did was I made it a 4. I broke up those 7 x's, and I wrote them as x to the 4 times x to the 3 makes x to the 7. That way I could take the 4th root of x to the 4 so that the 4's would divide into each other evenly. Let's keep going. We started working on the y's. We took the 4th root of y to the 8. That gave us y to the 2nd. Y squared, that 2, it cannot be divided by the 4, so I'm going to leave the 4th root of y squared there. And finally, it's the 4th root of z to the 8, which, based on logic that we just talked about, the 8 divided by 4 gives us the 2. It's just a different variable holding it up. Nice. Let's make one more pass through this thing and see if we can clean it up once and for all. I've got a 5 times a 2 and no more numbers, so I'm going with the 10. And then let's look for stuff that's not still stuck under a 4th root. I see a multiple of x, a multiple of y squared, a multiple of z squared, And then this fourth root nonsense that we're still stuck with, we have to multiply all of that by the fourth root of, I see a multiple of 4 under the radical, I see an x to the third in the radicand, I see a y squared in the radicand. All of those were under that fourth root symbol, and that, ladies and gentlemen, is your final answer. So taking these exponents over here and breaking them up into more convenient pieces was helpful to me when it came time to actually simplify this expression. I guess we should do, well, this one's not very exciting. I'll just give you the answer. It's the fourth root of y to the third, because that can't be simplified at all, over the fourth root of 81. 81 is 3 to the fourth power, so this ends up being the fourth root of y to the third over 3. Now, what I was thinking about telling you about is a shortcut. What if I need to take the third root of x to the 6? Well, I could take this and write it as x to the 6 to the 1/3 power, and then multiply the powers together and get x to the 6/3, and then do the division. 6 divided by 3 equals 2, so this is equal to x squared. That's nice. Now, what if this said the cube root of x to the 7? Well, I'm going to skip those middle parts. I'm going to go directly to x to the 7 divided by 3. And that doesn't work out so well. What is 7 divided by 3? Well, 3 goes into 7 2 times with a remainder of 1. How many times does 3 go into 7? It goes in 2 times with a remainder of 1. We could have taken the x to the 7 and written it as the third root of x to the 6 times the third root of x to the 1, which would equal x to the 6 to the 1/3 times the third root of x to the 1, which equals x to the 6/3 times the cube root of x to the 1, which equals x squared times the cube root of x to the 1. Geez, since those are the same answers, I like the way that we worked through it in red instead of going through it in blue like that. The red way was considerably faster. I like that shortcut that was 7 divided by 3 equaled 2 with a remainder of 1. Takes a little practice to get good at using that shortcut, but it's doable. These are pretty much the same, they're just kind of annoying. Because there's a denominator under here, you've got some simplification that you might have to do. Otherwise, tackle the numerator just like we did in the previous problems, and then make sure if you have to cancel anything out that's in the denominator. Parts B, C, and D are really the same. You've got to take the third root and the fourth root and the fifth root and apply them to the numerators and denominators separately. Then do some simplification. Can I give you an answer for this one real quick? Yeah, part C is pretty fast. This is equal to 4x squared over y to the 6z. What about this one? Part B is a little bit more cumbersome. It's going to be negative. Oh, it's the third root of 120. I don't know what the third root of 100. Oh, well, 120 over 4, that can simplify. 120 divided by 4 is 30, which stinks. There's no cube root of 30, so we're going to stuck with the cube root of 30. So we've got the negative sign there, and then the... So again, you should go through this on your own. I'm just giving you a solution. I've got an x squared, I've got a y, I've got a z to the third. I don't want to do it that way. We want to simplify this thing. Okay, now that I've made a mess of this, let's talk about it together. This is equal to negative the cube root of, and because this stuff underneath here can be simplified, let's simplify it. The 4 goes into 120 30 times. X to the 7 over x to the 4 makes x to the 3. Y to the 5 over, oh, there's no more y's, so y to the 5. And z to the 9 over z to the 2 makes z to the 7. So now this problem is the same as previous problems that we were working on. Your final answer here is negative x, y, z squared times the third root of, the 30 didn't simplify at all. X to the third, we totally tackled that. 3 goes into 5 once. Carry the 2, so that's a y to the 2. 3 goes into 7 twice with a remainder of 1. There's the twice, there's the remainder of 1. So see if you can make your way through that problem on your own. Right, just copy down this original problem onto a separate piece of paper and see if you can simplify this thing and tear it apart without looking at the couple of steps that I wrote out in order to get to a final answer. Part D. Here's the b. Here's the b over a squared, and then the fifth root of a to the 22. How many times does 5 go into 22? Say 4. 4, very good. So it goes in 4 times, so I'm going to multiply by a to the 4. And then what's the remainder? The remainder is 2, so there's an a squared. And that's going to be staying underneath the fifth root. And then in the denominator, how about the fifth root of b to the 25? How many times does 5 go into 25? Oh, it goes in 5 times. Perfect. So here's times b to the 5. And the fifth root of a squared is all there is. There's nothing left in that denominator. So let's clean this thing up. There's a b in the numerator and 5 b's in the denominator, which means I'm going to be left with 4 b's in the denominator. Looking at the a's, I've got 4 upstairs and 2 downstairs. When I simplify that, I do the upper exponent minus the lower exponent, which gives me a to the second power. So there's my a to the 2. Now, under the fifth root still, we had another a squared. And this ends up being your final answer. A squared times the fifth root of a squared, all divided by b to the 4. It's a little weird. And by weird, I mean new to some of you. Determine the length of the third side of the right triangle. Use the Pythagorean theorem. A squared plus b squared equals c squared. In this case, a is a 6, or 12 is the a value, either way. So you've got 6 squared plus 12 squared equals c squared. That's 36 plus 144 equals c squared. 36 plus 44 is equal to 180. So we've got 180 equals c squared. We'd like to take the square root of both sides. The square root of 180, well, 180. 180 definitely contains a 9. If my pen will work. And it's 9 times 20. 20 is 4 times 5. And when I take the square root of that, which I have not done yet, so get rid of that square root, now we can take the square root of both sides. The square root of 9 is 3, the square root of 4 is 2, and the square root of 5 is yucky. So we'll just leave it in radical form as the square root of 5. Do the multiplication of the 3 times the 2, you got yourself a 6 square root of 5, and that's your hypotenuse. Go through the same process in part B. You should get an answer of 24. That's one of the famous Pythagorean triples, the 7, 24, 25 triangle. That was in the same group as the 3, 4, 5 triangle, 5, 12, 13 triangle. There's the 7, 24, 25, and the 8, 15, 17. You might want to memorize your Pythagorean triples. That would allow you to do part B here without doing any work at all. All right, that is a very quick tour through a section involving the simplification of radicals. I hope that gives you a good start in your understanding of the process of simplifying radicals. I hope that this little shortcut that I wrote out for you up here ends up coming in handy. This one that I wrote in red here, that idea of doing the division and getting the remainder, okay? If you didn't get it the first time, go back, check it out again. My guess is that you're going to run into a time when that comes in handy. Maybe real soon, maybe on a quiz. All right. I'm off to one more section. I think we're still simplifying radicals in the next section. Let's go see. There should be something for you to click on, like right down there, and then I'll meet you in the next video. Thanks, see ya.